Let's look at the last example, example 6, solve a polynomial inequality by graphing. Now we have inequality, but it's a polynomial inequality. So remember, inequalities in other functions, linear functions or quadratic functions, you still need to solve by graphing a lot of times when you have a systems of functions. But here, now that we have a polynomial inequality, we don't have to, it's not a systems, so we don't have to shade or anything, but it'd be still helpful to graph and see if the graph will be positive or negative. So for example, let's look at this inequality. What are the solutions of x cubed minus 16x less than 0? So we're looking at this function, x cubed minus 16x, when this is less than 0, so when this is negative. So in order to solve this, we want to figure out the zeros of this function, and if the function is negative, then it makes sense. So for all the values that are less than 0, that would satisfy our solutions. So we would have a lot of different solutions. So our solutions would also be inequalities. Okay, so first of all, let's try to figure out the zeros. When you factor this out with the greatest common factor x, you'll get x squared minus 16. This is a difference of squares, so you could factor it out using x minus 4 and x plus 4. Now we have 3 factors, so we know that the zeros are 0, positive 4, and negative 4. Right? So we know the zeros. How do we know they're positive or negative? You have to check the intervals. So pick any numbers that are less than negative 4, greater than but less than 0, greater than 4 but less than 0, and then greater than 0, less than 4, and then anything greater than 4. And then you'll see that the graph is negative here, positive here, negative here, positive here. So your solution to this inequality is anything that's less than 0. So all these y values are less than zeros in your function. So the red parts are all the solutions. So how do we write all these solutions? Well, we can't really list everything, so you're going to use inequalities. Anything that's less than negative 4 for x, and anything greater than 0 but less than 4 would give the solutions that are true for this inequality. So yeah, so you'd have to write the final answer in inequality. So a lot of times your solutions for inequalities would just be intervals. It looks like it's an interval, and it is, because we're looking at all the solutions in the interval. Okay. All right. So let's look at try number 6. What are the solutions of the inequalities A and B? So pause the video, see if you can figure it out by yourself, and come back when you're ready for answers. Okay, are you ready? Let's look at part A. First of all, you have to know the factors of this inequality, to this polynomial, to figure out the zeros of this function, right? So this is a function that you could factor out using greatest common factor. So factor out, your first step is to factor out 2x. That's your greatest common factor. And you have the polynomial x squared plus 6x plus 6 left over. And that should be less than 0. And then we know that 1, 0 is 0, right? And then we'd have to figure out the zeros for this function. We can't really factor this out by just factoring by grouping or completing the square, or yeah. So let's use our quadratic formula. Okay, so quadratic formula. In order to use quadratic formula, we need to identify a, b, and c. A is 1, b is 6, c is 6. So our quadratic formula, plugging in our quadratic formula, we have, where's my pen? We have -6 plus or minus root 36 minus 4 times 6 and then all over 2a, which is 2. And then, so this is x. And so this will simplify to negative 6 plus or minus 2 root 3 over 2. And that's simplified to negative 3 plus or minus root 3. So we know that the zeros of this equation would be 0, negative 3 plus or minus root 3. And yeah, let's separate that so that we can see it as separate zeros. Okay, and then yeah, negative 3 plus root 3 is about negative 1.2679 dot dot dot, and negative 3 minus root 3 would be about negative 4.73. So as you're imagining the graph of this function, yeah, we have negative 1, we have 0 here, and then negative 1, if negative 1 is here, your negative 3 plus root 3 would be a little bit less than that. And then negative 2, negative 3, negative 4, negative 5. And negative 3 minus root 3 would be a little bit bigger than negative 5. And so we have these 3 zeros. We have to check our values for the intervals, any values in these intervals. So if we check negative 5, we get negative 10 in our equation and in our function polynomial over here. So then this is going to be negative. Okay, and then if we check negative 2, we're going to have negative 2, 8. So here is positive, so we're going to have a positive. And then from here, negative 1, if we check negative 1, because negative 1 is greater than negative 3 plus root 3, it's part of this interval, not this interval. And so if we check negative 1, comma negative 2 would be another point, and so it's going to be negative, and then come back to 0, and then if we check 1, it's going to be 1 comma 26. So yeah, plug in your x values here, and then you'll be able to figure out 1 squared plus 6 times 1 plus 6 is 26, and so on. And so you can check the positive and negative values. And then now we have to think about our solution. All of this has to be less than 0. So anything less than 0, when your y value is less than 0, would be your solution. So this part and this part would be our solution. Okay, so yeah, first you figure out the zeros, and then you look at the intervals and see what satisfies your original equation. Okay. Yeah. So your solution would be anything, these intervals. You have to write it in inequalities. Anything that's less than negative 3 minus root 3, or anything that's greater than negative 3 plus root 3 and less than 0. So negative 3 plus root 3 less than x. X is greater than that, but less than 0. Okay, so this would be your final solution. All right, using the same method, you can solve for B. But you have to check the zeros and then check the positive and negative values. Yeah. So the solutions for part B using the same method, it's the same steps, will be x less than negative 2, or anything between negative 1 and positive 1, or another one, x for anything greater than 3. So you have 3 different intervals that are positive in this situation. So you probably have a graph like that where we have this part and that part satisfying our inequality here. All right. So that was the last example of lesson 3-5, zeros of polynomials. So the function that we looked at would be anything that looks like this. We have factors, right? For example. And so sometimes we have the square of the same factor or cube of the same factor, right? That just means it could be our turning point at exactly 0 when y is equal to 0. So the multiplicity of 2 has a turning point at the x-axis, and the multiplicity of 3, which is an odd number, crosses the x-axis, but will have like 2 turning points. So like there is a little curve going there, and then another little curve going down, and then you have another turning point here, and then this is just the 0 that goes through. So if you think about the multiplicity, it saves a lot of trouble by when you're checking for positive and negative values here, right? So if you just check one interval, if this is positive, if you know this is positive, and you know this is just one factor, or this is a factor that has a multiplicity of 2, then it has a turning point here, and then this is going to be positive, right? So you don't have to pick a number for this interval when you know the multiplicity. You can just use the knowledge. So for example, here try number 6, you know that the factors are x 0, x and x plus 3 minus root 3, and then x plus 3 plus root 3, right? So these are the factors, and we know that they're all going to cross the x-axis because there is only one an odd number of multiplicity, so it's going to cross the x-axis. So if we check the first interval, right, this is negative, so then that's going to be positive, that's going to be negative, that's going to be positive, right? So if the factors have multiplicity, then you know if it's going to be, there's going to be a turning point on the x-axis, or if it's going to just cross the x-axis even though it's a turning point. All right, good. So that's the summary of our lesson. We will continue with the next lesson in the next video. Bye.